All right, guys, this is the 2012 BC exam number 2. And this guy is a parametric question. Looks to me like the parametric questions won't be assessed on this year's BC test, but I still think it's good to go through these guys. So, you're given at time 2, you've got a position of 1, 5. You've got dx dt and dy dt in your givens. All right, part A, it asks about the horizontal movement at time 2. So dx dt is what's telling you about the movement in the horizontal direction. So all you got to do is plug a 2 in where you see t. So, and square root of 4 over e squared. Well, both of those guys are positive, so that has to be greater than 0, which means this guy is moving right. Okay? Second part of this question, it says find the slope of the path of the particle at time 2. So remember in parametric that dy dx is equal to dy dt over dx dt. So I've plugged a 2 into dy dt, I've plugged a 2 into dx dt, and then push buttons, and I got 3.055. Okay, part B, it says find the x-coordinate of the particle's position at time 4. Okay, so it's just asking about x, so I don't have to worry about dy dt at all. And I have an initial condition. I know that at time 2, the x-coordinate of this guy is 1. So I have 1 plus the integration starting at 2, going to 4 of dx dt. Button pushing at this point, 1.253. Part C, find the speed of the particle at time 4, and then find the acceleration vector of the particle at time 4. So this is just plugging into formulas, really. You know that your speed equation is the square root of x prime of t squared plus y prime of t squared. You're just subbing 4's in, and you push buttons, and you get 0.575. All right. To go from the velocity vector, which these guys are kind of like the velocity pieces, to the acceleration vector, well, you just need to derive this guy to get to his second derivative and then plug in a 4, and derive this guy to get his second derivative and plug in a 4. Now, this is a calculator question, so you can totally just use Math 8 and type that stuff in, and then type evaluated x equals 4, and you're done. Okay? And then part D, it says find the distance traveled by the particle from time 2 to time 4. So again, you have an equation for distance equal to the integration of. This is basically speed, right? It's because when you integrate speed, you're going to get how far you went. So again, right here, you're just pushing buttons. And when you do, you get 0.651. All right.